Fantastic. Okay, so this is probably going to be a pretty small group because we announced it quite late. Unfortunately, because it's going to be a good one, we're going to demo some of the Synapse things that are actually up and running. So to give you guys a high level, as you guys know, we've been pushing this for a long time. We want to get the synapses out high setting, and we're going to launch Nobunaga testnet for synapses, so you guys can check your miners next weekend. And that will be sort of, then we'll test it for a little while, and then you get in preparation for its launch on Nakamoto. So, this talk will, if you're here, it's going to be kind of insider, knowledge, because you'll get to see how you can run a miner and what considerations there are about, how that's going to run, and you'll have an advantage when we launch in 2 weeks. Hey, Ann, welcome to the call. Zoro, welcome. So this is going to be in conjunction with me and Eugene. We're gonna basically go through the process of running a new miner on Nobunaga. So Eugene, do you want to maybe get your screen up? And there you go. He's ahead of me. Yeah.
Okay, sounds good. Okay, so I guess I'm going to take you guys over what happens when you're running a miner on the new Synapse branch. So we've made it so that it is as similar to the current Nakamoto system as much as possible. You'll see a lot of the similar things here. Majority of, I'll try to go through everything that we've changed, so we can document all the changes. So BT-cli run will still be the sort of one of the major ways that you can run your miner. You can also call it directly by just calling the miner itself, and both of those ways would work. So when you do BT-cli run, again, you'll be prompted by the network. So in this case, we're going to go to Nobunaga. Your wallet name. So I'm just going to use the default wallet. And here's sort of one of the major changes that we've changed is that we've actually combined the Synapse update. We've combined the advanced server and the template server into the same thing. So we called it the core server. And so the core server actually can do both the advanced server and the template server. All you have to do is to set the right flags, and you'll be able to get the advanced server or the template server as you wish. By default, the core server acts as if it is a template server.
Which means that it doesn't perform training as well.
Yes, there's no training involved at all with the core server by default.
Yeah.
You can turn it on; it works all the way. Okay, and so here's the major update, the Synapse update. So after you prompt basically what miner you want to run, you will also be prompted by the synapse that you want to have on the server itself. By default, all 3 synapses will be turned on. You could basically, if you're running a very specific model and you only want to turn on a specific synapse, you feel free to just type it in, and then it will turn on only that synapse for you. Okay, so by default, we're just going to turn on all the synapse.
Which makes sense. So you would most likely not want to ever change that parameter, especially if you're trying to seek out high ranking in the network.
Okay, so as you're starting, it's very similar to what you guys would expect on Nakamoto. So okay, so here we go. So I've already registered on Nobunaga, so I have UID 0, and now it is just syncing the metagraph. Okay, so now let's move over to my notebook here.
So this is a running server. What model are we running over here? GPT-2?
This is just the default GPT-2. So
okay,
very basic, very simple. Okay, so now we're going to actually query. Now that we have a server started on Nobunaga, we can actually query it using this notebook that we have. So here, okay, so one of the major updates is we're actually dividing up different types of work into different synapses. So first one we're going to go over is the last hidden synapse. And the last hidden synapse is basically almost exactly what we are doing right now. So basically, servers will reply with text embeddings with the size of 1024. And basically, all you have to do to enable last hidden is that you have to first call this synapse object and give it that you want the last hidden state synapse. And you have to attach it as you send a request right here. So as you attach it, as long as you tell which synapse you want to, then you will be able to fire a last hidden state request over the wire, and then the server will reply with 1024, which is the embeddings that I'm sure everyone here is familiar with, is basically what we're doing right now on the Nakamoto network. Room, but I can't hear you on Discord. Can anyone hear Jake? Is it just me?
No, I cannot hear Jake either.
Discord being problematic. Can people hear me now?
Yes, I can hear you now.
Yeah, we can hear you.
Okay, that's great. Okay, thank you. What I was saying was that the embeddings are obviously, not interpretable by us. They're not human interpretable, but one of the things that we're changing here is we're making BitTensor much more user friendly, as in human friendly, because embeddings are clearly machine interpretable. They're high dimension. They encode the massive amount of information, but synapses are an extension of this. They're essentially the heads of the machine learning model that take the inputs through the embeddings and then project them to something that is understandable by us, in natural language, for instance. So that's, I think, Eugene, you're just showing us off kind of what BitTensor already does. So this is nothing new for most people on the. But let's continue.
Okay, yeah, and so this is sort of the next synapse that we're going to talk about is the causal LM synapse. So the causal LM is essentially what we do, what we're trying to accomplish as we're trying to train our models. This task is asking the models to actually predict what the next token/word should be. And what it's going to do is that it's going to reply with a probability distribution of the tokens that it thinks the next word/token should be. So again, very similar to before, we're going to have to define our synapse. So in this case, we defined it to be the causal LM. We make sure that we're sending to UID 0, which is the UID that I started up just now. And so all we're going to have to do is we're going to send a sentence of "Hello, my name is" over to the server. Okay, and so we're going to fire it over the wire, and then it's going to hit my server, and then the server is going to reply with basically a probability distribution of what it thinks the next token should be. And so we can actually decode that and actually see what GPT-2 thinks the next token should be. So the highest probability is John, or something with a capital K, or something with a capital J, and you guys can all see here the top 5 sort of predictions of what GPT-2 thinks the next token should be. Okay, so that was causal LM. So now we're gonna move to.
So wait, let's pause here and look at this. Look at this, the output right here. So causal LM is majorly for doing validation. So we're looking at "Hello, my name is." We're looking at the next tokens in the sentences, and their probabilities assigned to those outputs by the model. It's this output that we use to do validation. In the future, this and what we're going to see, text sequence to sequence, will be combined. So there will be no difference between these synapses. But the way that language models work is they produce a probability distribution over the tokens, and that's how we do generation. So what you're looking at from the output here is you're looking at the output of a potential generation. So we know that we're going to go, "Hello, my name is John." Then we can pick that with some probability, with a probability distribution, and then continue generating forward. Great, correct, Eugene?
Yes, exactly.
Yeah, cool.
Any questions about causal LM synapse? If not, we will take questions at the end as well.
I just have a quick question. So with all of this in place, after obviously we've picked the model that we want to run, do we have to input any of this, or is this just running in the background basically once we picked a model to run on Synapse?
So what we're showing here is just us demonstrating sort of what's happening behind the scenes.
Yeah.
The next synapse is something that you can actually play around with and you can actually use yourself. What's happening here with the causal LLM is what the validators are doing under the hood. So they're asking the servers to predict the next token and then seeing how good they are performing to basically rank them on the network.
Yeah.
Oh, right.
And
Okay, that makes sense.
So you could do this yourself. It just, I think, is less fun than what we're going to show you in a second, which is, I think more valuable to you guys. So.
Oh, right. Brilliant. Yeah. Thank you.
Yeah. No worries, man.
All right. So now moving on. So the last and the final synapse that we're gonna, I think, have for the launch is the seek-to-seek synapse. So basically, the seek-to-seek synapse is a task where the validator or whoever is sending it will ask the servers to generate a sequence of text. So not just the next token, but actually generate me a text given the prompt that I sent over. So again, very similar to basically causal LLM, we define the synapse to be seek-to-seek. And then here, num to generate is basically the number of tokens to generate for me, so 100. And then beam search is something that we might discuss a bit later, but essentially it's basically how much, the higher the beam search, generally the better the result, but also the longer it will take.
Essentially, it's the number of unique sequences that the model on the endpoint will try in order to find out the one that's most probably the one that you want. So it's like essentially searching the space of potential sentences given the prompt. Did that answer well? Correct. Well, Eugene.
Exactly that.
Okay.
Okay. Yeah. So to demonstrate, so seek-to-seek, we're going to send the same prompt we did before. So hello, my name is to the server that I have running right here. So you can see that it received a seek-to-seek request, and then it replied with 100 tokens in about 5 seconds to generate 100 tokens. So we can basically now look at that sentence and see how what GPT-2 will generate given the prompt "Hello, my name is." So, Jake, do you want to take it over?
Sure. The prompt was "Hello, my name is." The prediction is "Hello, my name is John, and I am a member of the Church of Jesus Christ of Latter-day Saints. I have been a Mormon since I was 12 years old. I grew up in Salt Lake City." That makes sense. I mean, it's making logical sense up until this point. That's pretty impressive. Yeah. Utah, where I attended Brigham Young University in Provo. I don't know if that is in Utah. Somebody correct me if I'm wrong. My father was correct the model. My father was a missionary in the United States, and my mother was an ordained minister in New York City. As a young man, I learned to read, write, write. Read, write, and write. In my ears. However, and then I guess we don't know the rest of this, what happened to this young, very religious man, because we haven't predicted enough tokens. So, but we could extend that, right? So if we were to say more tokens, say 200 tokens, we could figure out what happened to this young guy after the however. There's lots of suspense here.
So you can see that sort of like causal LLM and seek-to-seek is a very like tied together. So you can see that like they predicted exactly John, which was the most probable token that causal LLM gave back,
right.
And seek-to-seek basically continued on generating the most probable from there on. So
what do we think? What do we think actually happened to him? Because it's like the however is so poised here to change the story. So he's clearly living a very religious life up until this point, and then what? He becomes an atheist, or he joins a Satan church. You would have to get some more tokens, but let's leave it to the crowd here. This notebook will be put up afterwards. You guys can generate more if you'd like to see what happens.
Yeah. So we'll leave it in suspense, a cliffhanger for everyone. Okay, so that was obviously, the first bit of the presentation, basically doing a server that I have running locally. So the power of the BitTensor network is that there are hundreds, if not thousands, of servers running at the same time. And this gives us a level of compute that is sort of not possible unless you're working with massive clusters of GPUs that are capable of running, hundreds of servers in parallel so that you can query all these people. With the BitTensor network, we're able to basically ask multiple network servers over the network to generate text for us. So what we're going to do is that we're going to do the same seek-to-seek, basically Synapse, and then we're going to actually send it to 4 different servers that's currently running on Nobunaga. And the sentence that we're going to be sending is going to be, I came, I saw, I conquered. So let's see what the servers all think. So you can see that they're all replying with what they think it's going to reply. So it's going to wait for the last one. Again, Jake, I don't know if, am I the one who, can everyone hear Jake?
Oh,
I can't.
cannot.
So Eugene, you're just hearing me through the wall or something?
Yeah, I hear you through the wall, and that's how I know you were talking.
Oh. Well, you can hear me now, though.
Well, anyways.
Okay, but Isabella can hear me, correct?
I can hear you now.
Okay, great. So you're running a GP. I was saying that the reason why we have 11 seconds on that one is because it's a GPT large. There's a billion parameter model, or like a 500 million.
It was the Neo, the 1.4.
Oh, it was Neo. Okay.
Yeah.
Okay, cool.
Okay, so basically we asked 4 different servers. So one of them was Distilled GPT, one of them was GPT Neo, one of them was a smaller version of GPT Neo, and one of them was a Spanish model. So Jake, you wanted to read what everyone said?
I came, I saw, I conquered. Distill GPT-2. I run a lot of Distill GPT-2s. I think I may stop doing that after I read this next prediction. I came, I saw, I conquered vernacular. Not a specific vernacular, just I guess all of them. So impressive, Distill GPT-2. I came, I saw, I conquered. I am the master of my fate by Rabindranath Tagore. Is that a real person? Don't
I do
know.
not know.
He conquered his fate though, so congrats to him. I came, I saw, I conquered, and I fought for you, and I won, but I was not strong, and I did not know how to fight. Interesting. And then a battle, an illustration of battle. We won, but he was weak. Okay. I mean, that says a lot about a Luther, but I mean, it makes sense. I came, I saw, I conquered, ill, and I want to go to a movie with the guy, the middle dude, and his kids and wife, right?
I do not know. I don't know how to read Spanish.
So the middleman, I think, that's what it says. So the Spanish model returns Spanish, which I think that's quite interesting, right? So we, in the cool thing about what we're building here is also that because the validators are using switch networks, they have the ability to, one of the cool things about the fact that we're using BitTensor is that the switch networks on the validators will be able to select, okay, so we're reading a Spanish sentence, we're going to talk to the Spanish model. Okay, this is code, so we'll talk to the model that understands code generation. And we get to stitch the models together into a collective model. So this is really cool. And also I think it's a lot of fun, especially when we build our playground, which is coming along. The user will have the ability to switch between different contexts and different models, and get a lot of variation, a lot of diversity when they're trying to generate text, which perhaps will be useful for people that want to do creative work, et cetera, et cetera. So we can put all of this together. We don't just get one model or query one model at a time. We can combine those outputs and build something that's greater than the sum of the parts. So yeah, let's continue, Eugene.
Exactly. So right. So like we saw here, where we send it to a Spanish model. Spanish generation is generation for languages that aren't English is entirely possible as long as a proper model has been set up on Nobunaga. So in order to sort of leverage as much power out of the Spanish generation, all you have to do is basically send over a Spanish prompt. So the prompt here is hola. I'm actually not going to read it in Spanish because I can't read Spanish, but essentially it's Spanish for hello, my name is. And you'll see as it generates that the generation becomes a lot better because once the prompt is in the language that it was originally trained in, that it will see a significant performance gain for that language.
Very cool. And so we can also generate off language models that are potentially not Spanish. And with a Spanish prompt, some of them, not all of them, will be able to return, reasonably coherent outputs. So even though in this specific case we've selected the Spanish model, in practice you won't know if they're a Spanish model, but you can seek through you can search through the models to find one that performs quite well for your language type. So that's what you're going to show next, correct, Eugene?
Well, yeah. So the next is going to be something a little bit more out there. So it's not even going to be in the same script as sort of the same Latin characters as English and Spanish. So we also have a Arabic model that's currently set up, and again, very similar to Spanish. So here is, I hope, Arabic for hello, my name is, and essentially by sending over the correct language, you're able to basically get the same level of generation that you would expect as if you're working in English. The other thing that I would also highlight is that there's actually a large number of parameters that we've built into this Synapse, the seek-to-seek Synapse, including, so I've just demonstrated a few here, basically similar to num to generate, which dictates the number of tokens to generate. There are a lot of other things you can play around with, like the number of beams, the top P, which dictates the probability sampling, and then also like the number of repeated words. How often do you want, in your generated sequence, repeated words and other various parameters like that.
Top P, Eugene, could you explain what some of these mean? So like num beam is how many sequences you iterate through. Can you explain sampling, top P, and obviously no repeat n-gram is self-explanatory, and num to generate was already passed over, but what do those two parameters mean?
Sure. So do sample, essentially all it does is that it basically does, so once a model generates a list of probabilities, it do sample essentially tries to look through that tree of probability and essentially go not just the next token, but go a single layer deeper to try to identify potential, higher probability generation, even though there may, you might have to first take a lower probability token to start with. In the end, by doing the sampling, basically you get a better result in the end. And top P essentially means basically the probability cutoff before for your sampling algorithm. So basically anything lower than 0.9, don't consider it. I can't hear you again.
That's weird. But I seem to have to leave and come back. But effectively, by changing the top P, you can move throughout the space of generations with more randomness, perhaps getting different inputs and outputs to your model to find something that you want to generate. Okay, great. Thank you for the explanation, Eugene.
Okay. All right, and that sort of concludes our little Synapse demo here. Is there? I guess we're going to open the floor up for any questions, comments, things like that.
Yeah, could you guys speak to like the decision with combining template and advanced server?
Sure.
Yeah. So,
no, you go for it, Eugene, please.
So the actual decision to do that was that they actually share a lot of the same code from both the template and also the advanced server. And so in order for the Synapse update, we wanted to basically collapse that as much as possible while still giving the freedom to choose how to train your model and where to train your model. We're keeping it as if it's like the advanced server. And so if the actual decision to collapse the two is more from a technical standpoint, so that it's easier to maintain, and also while keeping the ability to train up to the user.
Functionality is just a flag now. Does that make sense?
Yeah, I think you were probably saying something before and it cut out, but yeah, I heard what Eugene said.
Oh God.
Do it again, Jake. Just try again.
Okay, I'll try one more time. It must be that I have really bad reception somehow. I don't know how that's possible. But it's effectively we're trying to remove code from the code base and make things simpler for the user's perspective. And the core server has both the advanced server and the template server functionality inside it. The only difference is that now it's just switching between them is effectively a flag rather than selecting a new code, a new file to run.
Exactly.
Yeah.
We'll also. Oh, Isabella. Go.
So I also have something to add about it. Basically, for the core server now, there will be two options. One of the options is to train it locally, and then the other option would be to train it remotely. So if you turn on both of the options, that would be equivalent to the advanced server. And then if you turn off both of them, which is by default, it would be equivalent to a template server. And then some of you guys may know or may not know, by local training, it means that like locally, just on your own machine, it does the training directly from the data set. And then by remote training, it actually means that we're actually doing the training or doing the optimization through the gradients from the validator side. So there is an option there. So usually we do recommend to fine-tune your own model because, as you know, model directly from Hugging Face, they are pre-trained but not fine-tuned. So if you are plugging in some of your own data set to a pre-trained model, it wouldn't be performing as good as those fine-tuned. So usually we do suggest turning on the local train option, but then for now, turn off the remote train option. Am I making it clear? Or do you have any questions?
Yeah, that makes sense to me.
Okay, amazing.
Jake, we can't hear you.
I don't know why that's happening, but it's very annoying. Effectively, I was saying that you want to what Isabella to stand as Isabella was saying, you want to pre-train your models before you serve them, before you start using the gradients from the network to get that head start. So that's and also the script that Ala presented last week, that will be incredibly valuable as well for people to take advantage of even a more advanced training setups before they can launch their model. So we're adding a lot of that functionality into the miners to make them more performant, to make them more intelligent, and ready for this. So there is one thing I think I would add also is that there's some of these models. Correct me if I'm wrong, Eugene, but some of these models can't on Hugging Face can't even be used with Synapses. Like there's a sort of like a limitation.
Yeah, so we're still working on exactly what type of models you are able to run. So right now, some of the BERT models can't run the Synapse update, and we're trying to basically devise a way in which that it would allow the BERT models to run causal LLM and seek-to-seek, but it's still sort of a work in progress right now. I would recommend anyone who wants to basically check out what type of models you can run to actually take a look at the text generation tab on Hugging Face models, and you'll be able to see the full list of text generation that will work out of the box with Synapse Update.
Eugene, can you still hear me through the mic?
Yes.
Okay, great, cool. Yeah, so the floor's still open for people if they have questions about what this is and how this works, and if any scoop about how we can run models better, etc. I noticed that in the general channel, Donk and Krill have confirmed that yes, in fact, the AIs know who they're talking about, and also which universities make sense for Utah. So that's quite cool to see, right? So there's like, these are pretty small models, but they understand context pretty well.
So am I right in assuming that Synapse is more rewarding for those that basically like train their own models rather than just kind of picking a package from Hugging Face and running it through Synapse?
People that even today, if people are doing the work to take their models and pre-train them on our data set, you're going to have an advantage in the network. And we just haven't built the tools for people, the tutorials to do that. We know that some people are, and it will be doubly so when synapses are released, because there's just the task at hand is more complex. The validation system is going to become much more accurate. There's going to be a lot less randomness in the way in which models are ranked. So you'll see that there's less variance in your ranks, and that it reflects very much more the size of your model, the performance of your model against standard benchmarks, because we're tuning down the raw combinatorial or synergistic, we say, qualities to the ranking mechanism, to the validation mechanism, and pulling up the individual ranks themselves. So it's more important to be just individually good as opposed to just synergistic or collaboratively, which turns down the randomness, the entropy in the system.
All right, so it's like more rewarding in the sense of like if you actually know what you're doing rather than just just kind of like picking a model and like keeping your fingers crossed and hoping for the best in that sense.
Yeah, because I know that there's a lot of randomness, and part of that is because the validation system as it is purely synergistic. So we take all the outputs as embeddings and combine them, but there's a fair amount of noise in that process. It's just like a fair amount of stochasticity in the way that those inputs could be joined. The new validation system is more intelligent about the way that it selects the minors. It not only produces a synergistic validation score, but it also produces validation scores which are independent of the others in the network. So it goes, hey, like, are you just good at doing text generation at all? And it doesn't matter it doesn't just look at the synergistic quality to the embeddings. And so that makes it much more accurate. It's much more explainable, and that's, I think it's a good thing. But where we want to go is towards the synergistic, bit tensor, because that's one of the things that we have. It's a collaborative aspect of machine learning. But we want to also make the validation process more understandable, interpretable by humans. So that's what we're working on. That's what will change probably when we launch Synapses. You can test this type of stuff in the Nobunaga branch next week.
Oh, brilliant! Thank you.
Yeah, and so this is I would also add, for people who want to take advantage of the Nobunaga test time, it would be a great time to actually see what type of models would be best, and also, we after the Synapse update, you will be rewarded for running larger models. So things like people who have larger computes and can run larger models, we'll see their incentives go up for doing that.
That's interesting. Thank you.
It happened again. It's so funny on my side because I can just hear Jake talking over through the wall. There's just nothing coming through.
For some reason, it's the reception with the internet here just drops out periodically, and then I lose. But what I was saying was that we've been testing behind the scenes how to ensure that the validation system actually is checking for model size, and if the mechanism can detect whether or not a model is actually better within a traditional sense, because it's a great little proxy for us to peer into the system and make sure the validation is working properly. So we're annealing towards a system that it does perform like that, in a way that makes pseudo sense. It's more interpretable by us, and we have discovered that yes, so larger models like billion parameter models will outperform the Distill GPT-2 that you saw a second ago in the demo. Girl says, in my country, they say that size matters. Yeah, well, in our network, well, size will matter, so, but not exclusively. And if you look, if you look at, say, the GPT Neo model, it's 1.6 billion parameters. GPT-2, which is only 100 and something 150 million parameters, tends to actually be performant on longer sequences, more performant on longer sequences than that model. And we still will actually be using the proxy of performance in the ability to do generation. So yeah, hopefully that answers your question.
Any chance we get the tutorial before the Synapse release? So before the Nakamoto release, definitely, but probably not before the Nobunaga release.
Any more questions? Hit us. Also, feel free to type in the general chat, everyone. I see that Zoro is typing, so we'll wait for him. But if there's no more question, can we get the link to the Jupyter Notebook so we can test? Eugene, is that ready to be released? Maybe day end today.
We will release the notebook and when we launch the Nobunaga test, because right now there's still a bit of security things that we need to fix out. But
okay,
once that's fixed.
Great. So it will be next week that we launch this with the tutorials, and you guys can just jump on it and hit it. So it'll actually come with the branch that works. Okay, thanks, Sora. Okay, no one else is typing in the general chat. The silence in the voice chat. So I take that as everyone was happy with the presentation and got what they liked and understood it. So let's break then. Have a nice evening, everyone in the East Coast. Have a nice night, everyone in Europe, and us West Coast people will continue working. So enjoy the rest of your day.
Thanks, guys. Have a nice day.
Yeah. Ciao.